Hey, 8th graders, we are on our last section of notes. We are still talking about systems of inequalities, which you guys saw Monday. We are just going to take it one step further because there are two things that we have to, that you might encounter. So the first thing it says is that systems of inequalities are not always in slope-intercept form, and that's the form that we need to be able to graph. So I'm just going to keep reiterating this. Let's solve the following systems of equations by systems of inequalities by converting to slope-intercept form before we graph. And remember, so this is the other little catchy part, is that if you divide by a negative, you have to flip the inequality sign after multiplying or dividing both sides by a negative number. So we did this back when we were just graphing on a normal number line, and so you guys might have forgotten it, but that's the only thing that we have to remember, is that we have to flip that symbol when dividing or multiplying by a negative. Okay, so I'm just going to take both my equations and I'm going to start, and I'm just going to get y by itself and get it in that form. So I'm going to move the x over to the other side. Now I like to write that right away, so it's minus x plus 6. Then I'm going to divide both sides by the 2. And remember, you have to divide everything by the 2. So this cancels. You end up with y is less than, and there's just a 1 there, negative 1/2 x plus 3. I didn't have to flip the sign because I divided by a positive 2, not a negative 2. Okay, so my next equation, I have 5x minus 2y is less than or equal to 6. So the first thing I do is move that 5x to the other side. Then I get negative 2y less than or equal to negative 5x plus 6. And then what I'm going to do here is I'm dividing by that negative 2. Well, if you divide by that negative 2, flip your sign. So this ends up being positive 5/2 minus 3. So make a note. Looking for my highlighter here. Must have lost it. Make sure that you note that you flipped that sign, or that you just keep in mind. And we're going to graph them just like we were doing yesterday. So, or on Monday. And so the first one starts at positive 3, 1, 2, 3, and negative 1 over 2. 1 over 2. This is going to be a dotted line because there's no equal to underneath. So it's a dotted line. And this is less than, so I'm shading below. Okay, now I'm going to graph my other equation, and that one started at negative 3. 1, 2, 3. The slope is 5/2, so 1, 2, 3, 4, 5 over 2. And then this is a solid line. And then this one is above, so we're shading above. And then we are going to, we are going to shade the region that they both share. And, oh, here's a highlighter. Sorry guys, being all sorts of noisy today. This is the region that they share. This is the solution to the inequality. Okay, going on to the next one. One equation is in slope-intercept form, or as close to it as we can, and then the other equation, I'm going to get the y by itself by moving the x to the other side. Then I have negative y is greater than negative x plus 3. And I divide both sides by a negative 1. Because remember, if there's a negative with your variable, there's just a 1 there. So then I have y, flip your sign. This ends up turning to a positive x minus 3. So my first equation is y, so it crosses my y-axis at negative 1, and it goes below, and it's a dotted line. So dot, dashed, whatever you want to call it, and going below. And then my other one is at a negative 3. 1, 2, 3, positive 1 for a slope. And it is also a dashed line. And you're shading below. Remember, those arrows should come off going down. And then you are going to shade the region that they share. So it's below the pink line, below the blue line. Okay. So our next one, I have 2x plus y less than or equal to negative 1. Just going to move this quickly over to the other side. I get y is less than or equal to negative 2x minus 1. Then that one is done. And then my other one is x plus 2y is greater than 4. And then I would just move that x to the other side. 2y is greater than negative x plus 4. Divide by 2. Divide everything by 2. Y is greater than negative 1/2 x plus 2. I didn't have to flip anything because I didn't divide by a negative. And then I am going to just graph my lines. My first one's at negative 1. Sorry, my phone is going crazy. Okay, the first one is at negative 1. And then my slope is a negative 2, 1, 2 over 1, 1, 2 over 1. And this is a solid line. And then I am going below it. And then my other line, I am going to start at positive 2. My slope is a negative 1/2. Down 1 over 2, down 1 over 2. As long as they have different slopes, they will cross at some point. And then this one is greater. Oh, shoot, it should have been a dashed line. Sorry, guys. Dash it. And then we're going up. Okay, so the region that they share is actually just this tiny little wedge right here. Okay, one more of these. So I don't have to do anything with this equation. I'm just going to take my bottom equation here, or my top equation, sorry, rewrite that. I'm going to move that negative 4x over first. Then I have a negative 3y is greater than or equal to negative 4x plus 3. Divide by negative 3 on everything. Now dividing by that negative 3, I've got to flip my sign. So y is greater than or equal to positive 4/3 x minus 1. So I'm going to go and I'm going to graph this line. I start at negative 1 and I go up 4. 1, 2, 3, 4 over 3. 1, 2, 3. And then this is a solid line. Flip my sign. And then my other line is x is greater than or equal to 1. So that means it crosses your x-axis at positive 1 straight up and down here, and it's greater than, so my lines would go this way. Oh, I forgot my other lines. Greater than, these would go up. So what region do they share? They share this little wedge right here. Okay, so that's how you would treat ones that are not in slope-intercept form. Not too tough. Okay, 2 more problems. Word problems, you guys' favorite. It says, we can even model real-world problems with systems of inequalities. Let's model the following word problems. Like before, making up the equation is probably the hardest part, okay? And so once you do that, it's a little bit easier. So Steve is going to have friends over. He's going to buy some bags of chips and some cases of soda. Chips cost $2 and cases of soda cost $5. He wants to spend under $35. So you guys had a lot of practice with these with the last ones. So chips are $2. So I'm going to say $2 for chips plus $5 for soda. And he wants it to be under 35. Under 35, so less than $35. He also knows that he needs at least 4 cases of soda. So when we are going to do this, we know that our soda has to be greater than or equal to 4. Okay. So the first thing I'm going to do is I'm going to take this equation that I formed here, and I am going to put in, you know, we should maybe think about X and Y instead, even though I did C and S. I'm going to have this be our X, and this be our Y, this be our Y. Okay, and that's going to help us over here. So let's do it. X is chips, and Y, so I'm defining the variable. And then I'm going to get this equation by itself. So 2x plus 5y equals greater than, less than 35, minus a 2x. 5y is less than negative 2x plus 35, divided by 5. Y is less than negative 2/5 x plus 7. Okay, so now I have these 2 values and I can graph them. So my first one, it starts at positive 7 on the y. 1, 2, 3, 4, 5, 6, 7, down to over 5. And this is a dotted line. And we would shade below it. This is our $35 limit. We can't go over that. And then the other thing that's limiting us is that he has to have at least 4 cases of soda. So you're going to go up to the 4, and we are going to have a solid line at 4, and it has to be greater than or equal to. Okay, so that means that there's this little triangle of possible combinations. So we have to stay above the 4 cases of soda, but we can't spend more than $35. Okay, and there's many situations where setting parameters like this is real. So it says, let's make sense of the graph by listing a few possible combinations. So in a real world situation, we have to pick nice numbers. We can't pick a half a can of, or half a case of soda, or half a bag of chips. So you are going to have to pick perfect numbers. So these points in here represent all the possible combinations that we could have, basically. Okay, and stay within, we can't go negatives because, you know, we don't have negative bags of chips and that kind of stuff. So let's just pick out a couple of different combinations. So for example, he could have 1, remember X is chips and Y is soda. So he could have 1 bag of chips and 4 cases of soda. That's possible. He could have 2, 1 and 4. He could have 3 and 5. He could have up to 4 and 4 he could have. Those are different combinations. I mean, you could pick any dot in there, but with this one, we just have to have whole numbers. Let's do one more example. Carol has a ton of children, but her husband is giving her whole day to herself. She wants to do 2 things: play guitar and read. She wants to play guitar for at least 3 hours and read for more than 2 hours. Okay? Although she has no more than 9 hours to do these things. Create a graph and a system of inequalities that show her options. Okay, so a couple things. We have some limiting factors. I'm going to have X be guitar and Y be reading. And this is hours. Okay, so we know that she wants to do 2 things. She wants to play guitar for at least 3 hours. So this one has to be greater than or equal to 3. And she's going to read no more than 2 hours. So her Y is going to be less than or equal, or just read no more than 2 hours. Oh, read for more than 2 hours. Sorry, I was looking at that wrong. And then it says, but we have a limit because we can't do both of them. When you add them together, they have to be less than or equal to 9. Okay, so this one we're actually going to have 3 situations. And so the first one, I'm going to get this equation, move that x over. Y has to be less than or equal to negative x plus 9. I'm going to graph that one first. So we're at positive 9, and it just goes down by 1. And this was shading below. Okay, then my other parameters are x is greater than or equal to 3. So my x would be right here. And that one's going to go vertical, and it's going to be solid. But she wants it greater than, so that would be going this way. Okay, and then my other one is, let's find another color, is y is greater than 2, so that's right here. We've got this line going here. That one's going to go up. So you have to find spots in here that's going to make it true for all 3 inequalities. And what happens, it's kind of hard to see with all these different colors, but there's this little triangle right here. It's above the green line, to the right of the purple line, and below the pink line. So we have to pick out some coordinates in here that would be true. So for example, she could read for 5 hours and play guitar for 3. Or play guitar for 5 and read for 3. Sorry, I had that mixed up. Or she could play guitar for, let's see, this is 4 and 5. Okay, or she, depends if she wants to maximize this or not. Or she could do it for less. She could even do one down here. She could do it for 3 and 2. Okay, so as long as they make it true for all of the cases. So that is all I have for you guys for notes. Your last little homework assignment is right here. How exciting. You guys are done. This is the end for the year. On this very back page, this is just going to be a helpful tool for when we have your guys' quiz and we study for that. Hope you guys are doing great, enjoying the week so far, and we will talk to you later.